I just made an amazing instructional video on how to do the surface area of an arch, but my mic was muted the whole time. So instead of erasing all of this wonderful math, I'm just going to walk you through it and point some things out that are of importance. So first I have these 4 pillars right here that are red that we're going to need to find the surface area for. And I have the semicircle cylinder right up here, right? This is like a cylinder that's had the middle just cut right out of it like a hole saw. So we're going to have this middle green part right there of the circle. And it's sort of like the outside of a cylinder, we could imagine, that it exists in this green circular piece there. And then we have the face of the semicircle arch, which is blue. And we're going to imagine that as the base of a cylinder. There's one in front, there's also one in back. And then we have the purple part on the outside, which we can see a little more clearly as the outside of a cylinder. And we're going to have to add all of those things together to find the total surface area of this arch. So first I like to start with the easy part, get these pillars out of the way. Now the dimensions are 1 meter by 1 meter by 6 meters tall. And there are a total of 1, 2, then the other sides, 3, 4, 5, 6, and the back side, 7, 8 of these. On your own models, you may have a wall connecting to these outsides here and the side there that you can't see. So you won't use those. But I know some of you do have a freestanding arch in your design, so you will have all 8 of these sides. So my calculations for this are 6, the height, times the width, times the length, times how many there are, which makes 48 meters squared. Now, of course, I'm using meters. I am scaling this. You are going to use either centimeters or inches, the exact dimensions that you have made your model to be. So those are the pillars. That's the easy part. Now we're going to go to the inside of the arch part here. Now, if we were to unroll this part, just like the outside of a cylinder, it's going to become a rectangle. Now, this rectangle, unlike a cylinder, does not cover the entire way around a cylinder. It's only half. So instead of using the circumference to do all the way around, we're only going to be using the half of the circumference. So half of the diameter times pi, or the circumference, would be the same as the radius times pi. So the radius of this is 2 meters. So I will use 2 times pi meters as the length of my rectangle. And the width is the width of the pillar here. It's the same. It's 1 meter. So 2 times pi times 1 would be 2 pi meters squared, or 6.28 if you do the math out, meters squared. Now we're going to do the same for the outside edge of the semicircle, which looks, like I said, more like a cylinder, but again, it's only half of the cylinder. To find the radius of this cylinder, we have to add 1 more meter to that of the green circle right here, the green semicircle, because it adds the 1 meter from this portion of the semicircle. So that gives us 3 meters total. That means that using the radius times pi formula, which we developed here, 3 pi meters times 1 pi meter. The width is the same as the green one. So if we calculate that out, it'll be 9.42 meters squared. And if we don't, it'll be 3 times pi meters squared. All right, and final, I have the semicircle here. And we're going to take this circle piece right here that I have. I took it, I copied it over here, so we could see that this semicircle could be drawn as a whole circle, and we're just going to subtract this green circle out. So this whole circle has a radius of 3, as we found for the outside of the semicircle. And then the inside circle has a radius of 2. So if we use the area formula, which is pi times r squared, we'll have the larger circle be 9 times pi meters squared, because 3 squared is 9, so 9 times pi meters squared is the area of the large circle, and we're going to subtract the area of the small circle out. So the radius is 2, so 2 squared is 4 times pi meters squared. And by doing that, we get 5 times pi meters squared. Now, we have double what we need here, right? Because we only need the top half to find this part of the arch. See, that's the same shape. However, this second half right here can be read as the back side. So we can use the top part as this side. And in our calculations, instead of doing the same calculations to find the shape on the other side, I can just use this bottom part to represent what's on the other side. Now, some of you may be using an arch as sort of an arch entryway, and this whole back side of the arch will be placed up against another rectangular prism, and you will not need to calculate any of this second part or the back sides of the rectangular prisms. But in this arch, we will. So I'm going to, instead of dividing this by 2 and then just adding another one, I'm just going to keep this 5 pi meters squared. So I kept it here, and I have 5 pi meters squared. To find what 5 pi meters squared is, I did some math here. 3.14 times 5 is 10 times pi, 31.4 divided by 2. So it's 15.7 right there. And I added these up, and that gave me 10 pi meters squared. And 10 pi meters squared is 31.4. So instead of adding up all these decimals, I did 31.4 plus 48 meters squared equals 79.4. And just this might be too confusing at this point, but those three together equals 31.4, which when we add to that equals a total of 79.4 meters squared. That is the surface area of our arch. I will send this on to Senor Compaños to see if he can show it to you on the smartboard. And if you need to see it because you're doing calculations at home, I am going to post this on the website and the Google Classroom. So good luck finishing your projects. We'll see you soon.